Hello students, today we will start the chapter number 3 of data structure using C. So here it is the first lecture of chapter number 3. Chapter number 3 depends on stacks and queues. The name of the chapter or unit is stacks and queues. The chapter is of 20 marks. Okay, so you can see the different unit outcomes of the chapter. So develop an algorithm to perform push and pop operations for the given item in stack. Secondly, convert the given expression from infix to prefix and postfix using the stack. Again, write the steps to evaluate the given expression using the stack. Develop a program to perform the given operation on a linear queue and write an algorithm to perform given operations on circular queue. So basically, what are the unit outcomes? So what you will get from this unit, what you gain from this unit is nothing but the unit outcomes. So here in this chapter we have to learn two different data structures, stack and queues. Okay, so you must have to know the basic concept about what is data structure, what is abstract data structure, like that. So the prerequisite for this lecture is the concept of ADT. Again, I am going to revise you that what is data structure. Okay, we as an software engineer, we have lots of data and we have to store that data on your computers. Okay, when we are storing or recording that data, so we are using the data structure, different types of data structures we are using. Why? To record or to save that data, and again we have to retrieve that data efficiently. So for both of these purposes, we require some different types of data structure. As per the application, as per the requirement of the customer, we have to design some data structures, and these data structures are used to save or retrieve the data from the data structure. Okay, so concept of ADT again. What is abstract data structure? So abstract data structure, in that the implementation details are hidden from the user. Okay, we have to develop some data structure as per the convenience of the customer. We have to design the data structure. So when we are designing the data structure, we have to write down some functions. Okay, so the user may know what the capabilities of the data structure or what functions we can use by that particular data structure, but user don't know how it is implemented. So I have already given you, if you have seen the first one two videos of this data structure using C. So what is ADT? I have given one example of mobile. So in mobile you can see that what are the different operations we can perform. We can click the images, and we can call a friend, and number of operations we can perform, but the implementation details of that mobile are hidden from the user. So that is the concept of ADT, that is abstract data structure. All we are learning are the data structures, and these data structure are the abstract data structure. Here we are hiding the implementation details from the user. यूज़र को पता है कि वो क्या क्या ऑपरेशंस होने वाले हैं, बट यूज़र डोंट नो हाउ दे आर इम्प्लीमेंटेड. मोबाइल में फ़ोन कैसे होता है, फ़ोन कैसे कॉलिंग कैसे होता है, ये हमें नहीं पता, बट जस्ट वी कैन कॉल अ फ्रेंड, इट इज़ नोन टू अस. Okay, so abstract data structure is the same. So some contents are hidden from the user, the implementation details are hidden from the user, and that type of data structures are called as abstract data structure. Okay, and in this lecture, today's lecture, we have to learn what is stack and the stack as an ADT. Okay, so what is stack? So you have seen different stack. So it is the example which is given, it is the stack of books. You can say stack of notebooks, stack of plates, so these are a particular item is loaded to one upon one, that is called as nothing but the stack. So this is the stack of book. So a stack is a linear data structure in which addition and deletion of elements takes place at the same end, and this end is called as the top of the stack. देखो क्या है, what is stack? It is a linear data structure. The different data items are linearly mounted. Okay, in which addition and deletion of element takes place at the same end. If you want to add the elements into that particular stack, or if you want to remove the elements, you have to use the same end. Okay, so this end is called as top of the stack. So in this example, you can see if there are a number of books, so this is the top. Okay, the topmost book is nothing but the, you can say it is the top end. Okay, if you want to remove the books, you have to remove the books from the top side. So the first book, the book which is on the top, we have to remove first, then the second, next one, and the next one, like that we have to remove the book. If you want to add more books, that means if you want to add something, then again you have to add it from the same end, and that end is called as top of the stack. हमें अभी उसमें जो रिकॉर्ड है हमारा उसमें whenever we want to insert or delete, है ना, two operations we have to perform, either we have to insert the record or we have to retrieve the record. So at both the times we have to use only one end, and that end is called as top of the stack. So here there are example, the stack of book हमने दिया है, इसमें top कौन सा है, the topmost element और topmost book जो है, it is the top. Here array implementation is also given, in that there are elements like 100, 200, 300, 400 which are given. Okay, the last particular place of the array is blank, so the topmost element in the array is 400. So that way we can point at a top of the stack. What is stack now? Again, the stack works on the LIFO principle. So that is last in first out. You can see this example, last in, हमने last में जो add किया है, whenever we want to remove it, we have to remove the last one which we have added. So 400 we have to remove first, then 300, then 200, and then 100 we have to remove. Same like that in the books also, stack of books, हमने जो last book ऊपर रखा है उसको हमें पहले निकालना होगा. So it is the last in first out principle. It means the last item added to the stack is the first item to be removed. Now here the representation of stack in memory. Now here in this data structure using C, we have to implement the stack by using the array. Array is the most common data structure we are using, and by using the array we are implementing the stack here. So how to represent the stack by using the array? Okay, you know what is array? So continuous memory locations are allocated. So here just we have to use some terms. We have to define the array, and then we have to define some terms which are related to the stack. So first term is the top. It is the location of top element of the stack. Then second is the max. It shows maximum number of elements that can be held by the stack. Okay, two particular pointers we have to add. First one is the top. हमने elements add करे. If there are 4 elements, so you can say the fourth element is at the top of the stack. So maximum size is 5. If the size of the array is 5, that is the max size is 5. So you can add 5 elements. So maximum number of elements that can be held by the stack is the max. Top, that is the location of top element. Okay, if the size of array is 5, so max is equal to 5, but only 3 elements are added, so the top is equal to 3. Okay, so max is equal to 5. In this example you can see the max is 5. Why? Because we can store 5 elements into this array, so that's why the max is equal to 5. And here top is equal to -1, that indicates the stack is empty. Okay, whenever we are inserting the elements into the stack, then and then only the top goes increasing. But when there is no element, that means if the stack is empty, at that time the top is at -1. Okay, your array will start with the 0th position. आपने array implementation देखा होगा, so always the array will start with the 0th position. हम जब भी implement करते हैं, it will start with 0, 1, 2, 3. The positions are marked as 0, 1, 2, 3, 4. Although the array is of 5, so we will start with 0, 1, 2, 3, 4. The positions of the array is from 0 to 4 if the array size is 5. ठीक है, so top is equal to -1, that indicates stack is empty. So if there are no elements, we don't have to go to the 0. So top is always before that. So top is equal to -1 when the stack is empty. Just keep in mind that when top is equal to -1, that means the stack is empty. Okay. Now look at this. Now the stack has 3 elements. Okay. First, when the stack is empty, at that time top is equal to -1. Okay. Now we have inserted A. When we are inserting the A, that means you have to increase the top by 1. So that's why the top is at 0. Then we have inserted B. Look at the diagram here. When we insert B, the top get increased from 0 to 1. So now top will indicate at 1. When we insert the third element, that is C, at that time the top is goes at position number 2. So when we have inserted 3 elements, okay, now the stack has 3 elements A, B, C at position 0, 1 and 2. Since max is equal to 5, we can insert 2 more elements in the stack. We can add and delete elements from the stack by using the push and pop operations. Okay, you can see we have inserted 3 elements. So first element will be inserted at 0th position, second element will be at first position, and third element will be at the second position. So there are only 3 elements now into the stack, so that when you say that if what is the top of the stack, so top is at 2. Which is the top element? C is the top element. So the position of the top is at 2. You can say top is equal to 2 here in this example. Although the size of max size of the array is 5, but only 3 elements are there, and so that's why the top is at 2. Now whenever we are applying some operations on the stack, some operations we have to perform. So general 2 major operations, or you can say 2 important operations we have to perform on stack are push and pop. Okay, when you are inserting the element, it is not like that just we are inserting element, we are pushing the element into the stack. Okay, we are pushing the elements into the stack. When we are removing the elements, it is called as popping out. So we are popping out some elements from the stack. So the operations name for insertion and deletion of an element from the stack are known as push and pop operations. So when we say stack as an ADT, now here also there are different functions which we want to perform on stack. A stack contains finite sequence of elements of a particular type. The operations on stack are, which are the operations we have to perform? So first operation, initialization. We have to initialize the stack to empty. Okay, whenever we are initializing the stack, so stack will be empty at that first time. So set top equal to -1. What we have to perform in initialize function? We have to set top to -1. So this is just the initialization of the stack. And when we are initializing the stack is empty, and that's why we have to set top to -1 at initial condition. Next example, next operation we have to perform is empty. Here we have to check is the stack is empty or not. Next operation is full, whether the stack is full or not. Okay, if there is space to add more elements, then that means the stack is not full. Okay, or if you want to remove the elements, and if there are no elements into the stack, we can say is empty condition is satisfied. So 2 operations we have to again check is empty and is full to check the stack is empty or full. The 2 next operation is push and pop. If the stack is not full, then add the element. What is the push operation? You have to insert the element. So when we can insert the element? When the stack has some particular space to insert the element. Okay, if the stack is full. So if you can say that if the max is equal to 5, that means we can insert 5 elements into the stack. And if you have already inserted 5 elements into the stack, and you also want to add more elements into the stack, then at that time your push operation will not work. If the stack is not full, then and then only you can add the element. Same for the pop. What is pop? To remove the element, the operation called as pop. If stack is not empty, then we can delete the element. If no element into the stack, अगर उसमें element ही नहीं तो हम क्या निकालेंगे? Okay, so that's why the pop operation only works when there are some elements into the stack. If the stack is empty, if nothing is there into the stack, we can't remove the element. Okay, push operation और pop operation, इन दोनों में major thinking है is empty and is full का. For both these operation we have to check is the stack is full or not. For the push operation, for pop operation we have to check is the stack is empty or not. If the stack is full, we cannot insert the element into the stack. If the stack is empty, we cannot remove the element from the stack. So for both these operations we have to perform empty and full condition. We have to check. Last operation is the display operation. We have to traverse the stack. Just we have to display all the elements into the stack, and so that's why the operation is called as display. So these are the basic functions which we have to perform on the stack when it is an ADT. It is the abstract data structure. We know these operations we can perform on stack, but we don't know the implementation details, or we don't have to show the implementation details to the user. So that's why this stack is called as an ADT. हमें यूज़र से छुपाना है कि हमने उसके इम्प्लीमेंटेशन में क्या किया है. हाउ वी आर चेकिंग दैट इज द स्टैक इज फुल, हाउ वी आर चेकिंग दैट इज द स्टैक इज एम्प्टी, हाउ वी आर इंसर्टिंग द एलिमेंट, हाउ वी आर इंक्रीमेंटिंग द टॉप. It is unknown to the user. We are hiding this from the user. So that's why the stack is an ADT. It is the abstract data structure. हम ये implementation details hide करेंगे user से. So that's why the data structure is called as abstract data structure. It is abstract. We don't know how it is implemented. Okay, so ये operations हमें perform करने हैं. यूज़र को पता है कि हम वी कैन इंसर्ट द एलिमेंट इनटू द स्टैक, वी कैन रिमूव द एलिमेंट्स इनटू द स्टैक, बट वी डोंट नो how they are implemented. So that's why it is called as abstract data structure. So these are the functions or operations we have to perform on the stack. Now we will learn the first operation, that is push operation, here in this today's lecture. So push operation, look at this. The process of adding a new element at the top of the stack is called a push operation. Okay, as the new element is added at the top of the stack, after every push, the top is incremented by 1. I told you before it, the initialization, the top is at -1. When we are inserting the element, top get increased by 1. So that's why the process of adding the new element is called as push operation. And whenever we add a new element at the top of the stack, after that every push, the top is incremented by 1. If array is full, no new element is added to the stack. If your stack is full, you cannot insert the element into the stack. And that particular condition, that means if the stack is full and we want to insert one more element into the stack, at that condition it is called as stack overflow or stack full. The condition is called as stack overflow or stack full. So just look at the algorithm for push operation. What we have to exactly do into the push operation. So to implement the stack, we have to declare one array which can store elements. Okay, now we have to perform the push operation only. So say if stack of max is an array which is implemented for implementation of the stack of max ले लिया हमने array, उसमें हमें insert करना है element by using the push operation. So for this push operation we are passing two elements, two parameters. First is stack of max and second is element. We have to pass the element and we have to store that element into the stack. So that's why we are passing two parameters for the push operation. What we have to exactly do in push operation? First step, we have to check for the stack overflow. That means we have to check if the stack is full or not. So how to check the stack is full? So if your top is at max -1, that means the stack is full, you have to just print overflow and exit. Okay, so you can revise the example again. So if 5 elements or the max size of the array is 5, we can insert 5 elements into the array, or we can insert 5 elements into the stack. It starts with 0, 1, 2, 3, 4. So max is equal to 5, but the positions are 0 to 4. So if we have inserted the elements, we are incrementing the top by 1. So 0, 1, 2, 3, 4. All, if we have inserted all 5 elements, at that time the top will be at the 4. Okay, top will be at 4. So at that time we can say that now the stack is full. So to check the stack is full or not, we have to check the top variable, and if top is equal to max minus 1, at that time we can say that the stack is overflow and we have to exit. Now if the stack is not full, what we have to do? If that particular condition gets false, we have to go to the second step. Okay, if the stack is not full now, then we have to go to the next step. We have to set top equal to top plus 1. We have to increase the position by 1 for the top. So top is increased by 1, and we have to then go for the step number 3, that is set stack of top equal to element. We have created a new top, and at that new top condition we have to insert the element which is provided by the function. So element जो हमने दिया है वह भी new top पे set हो जाएगा. So this is a simple algorithm for push operation. So look at this now. So stack operation, push operation कैसे perform होगा? Basically when we are initializing the stacks, at that time top is equal to -1. Okay, top हमने declare कर दिया, it is at -1 because there are no elements. Now whenever we want to insert the element, so say I want to insert one more element, I have to push element into the stack. So at that time you have to increase the top by 1. So top अगर पहले -1 पे था, so we will go for top is equal to 0. अभी top आ जाएगा 0 पे, and then we have to insert the element. So say if the element is 100, we have inserted it at the position 0. Okay, again next again I have to push one more element, that is 200 at the stack. So what we have to do, we have to again increase the top by 1. So I have increased the top to 1. 0 में हमने ऐड कर दिया 1, so it is 1, the position is 1. Now at position 1 I can insert the element 200. Now here in this example you have to push 300, that means you have to insert 300 into the same stack. So अभी top है 1 पे है आपका, 2 elements already हैं उसमें. So we have to first check if the stack is full. No, it is not reached to max minus 1. top कितने पे है आपका? top is at 1. max minus 1 कितना है? max is 5 because 5 elements we can insert. So what is the condition to check the stack is full? So if top is equal to max minus 1, अगर top की value 4 है, then we can say that the stack is full. Now here the value of top is 1, so that means the stack is not full and we can insert the element. Okay, so what we have to do, we have to increase the top by 1. So देखो यहाँ पे हमने increase कर दिया top की value, एक और add कर दिया उसमें. So top is equal to 2 now, and then we have to insert the new element at the new top position. So हमने 300 वहाँ पे push कर दिया, and this is 300 which is at the position number 2. Okay, so ये push operation हो गया stack का. Okay, नेक्स्ट लेक्चर में हम लेंगे उसका पॉप ऑपरेशन एंड अल्गोरिदम ऑफ द पॉप ऑपरेशन. डिपेंडिंग ऑन दीज ऑपरेशंस वी हैव टू परफॉर्म सम मोर एग्जांपल्स ऑफ स्टैक ऑपरेशन, है ना. बहुत सारे यूजेस है स्टैक के, सो वो हमें देखने हैं नेक्स्ट लेक्चर में. सो अब तक के लिए यही है कि पुश ऑपरेशन, व्हाट इज स्टैक, व्हाट आर द फंक्शंस और ऑपरेशंस वी कैन प्रोवाइड बाय यूजिंग द स्टैक, व्हाट इज द एल्गोरिदम फॉर पुश ऑपरेशन, हाउ टू, और पर्टिकुलर एल्गोरिदम जो हमने कर दिया, तो उसके बाद हाउ टू पुश एन एलिमेंट इनटू द स्टैक एंड हाउ टू रिमूव द एलिमेंट फ्रॉम द स्टैक. वी हैव टू लुक फॉर द पॉप ऑपरेशन in the next lecture. Till that, just revise all the things again and again. If you have any doubts, you can ping me personally. Thank you.